Okay, so solving by elimination, we want to get rid of one of those variables. So in part A, because both of my x's are by itself, it's an easy fix for me to just multiply one of those by a negative. So that way when we combine them, we will eliminate that x variable. If you don't want to do it to the x, you could also eliminate your y variable because you see that you have a negative y and then a positive 2y. So if you were to multiply that first equation by 2, you would have a 2x minus 2y equals 2, and then your y variables would cancel out when you combine them. It does not matter which route that you choose. You should end up getting the same answer regardless. So I'm going to go ahead and make my first, I'm going to multiply that first equation by a negative. So that means I get a negative x plus y equals a negative 1. And when I combine it with the second, I notice my x's cancel out. I get 3y equaling 6. Solving for y, I get y to be 2, which is great. I'm obviously not done. I can plug that y value into either equation and then solve for x. So let's say I plug it into this first one. That would be x minus 2 equals 1. Adding that 2 over, we would get x to be 3. So our answer is 3, 2. Again, if you would have multiplied that first one by a 2 and canceled out the y and solved for x, you would have gotten the 3, and then plugging it back in, you should have gotten y equals 2. It's whatever you think is easier. In part B, I'm still trying to use elimination. So I have a 3x and a 4x. I have a 4y and a 5y. So there's not going to be a way that I can just multiply one of those equations by a number and it cancel out with the second. I'm going to have to multiply both by some number so that they will cancel out, that either variable will cancel out whenever I combine them. So again, it's up to you. If I'm looking at my x variable, I see a common factor of 12. So I can multiply the first one by negative 4 and the second one by 3, or vice versa. If I'm looking at the y variable, I see that common multiple would be 20. So then I multiply 1 by 5 and 1 by 4, making either one negative. I'm going to go ahead and go with my x's again, just so it'll be a teeny tiny bit smaller. I'm going to go ahead and multiply this first one by a negative 4, and then I'll multiply the second one by 3. Because the 3x is positive and the 4x is positive in the original two equations, I need to multiply one of those equations by a negative something. It could have been the negative 4 like I'm doing here, or it could have been the negative 3. It doesn't matter. I'm just choosing to go negative here. So that means this is going to turn into a negative 12x minus 16y equaling a negative 80. And then the second one will be 12x plus 15y equals 30. And so when I combine those two together, the x's should cancel out because that's how I chose my numbers to multiply by. Negative 16y plus 15y is a negative y, equals negative 80 plus 30 would be a negative 50. Dividing by that negative, y is 50. Awesome. I still need to find my x value. I'm going to take that y and I'm going to plug it into either one of my original functions. It doesn't matter which one. So let's say I plug it into the 3x plus 4 times 50 equals 20. So that would be 3x plus 4 times 50 would be 200 equals 20. That means 3x equals negative 180, which means x equals negative 60. And so then my solution is negative 60, 50. Okay. So notice in example 4, we have solving by any method without a calculator. Any method without a calculator. So this is really going to help you kind of look at a system and decide which would be better for me and my skills. And it kind of depends on the problem and it kind of depends on you. So when I look at the first one, I do notice that both substitution and elimination would be extremely easy here. Elimination, I can multiply my first one by a 3, and that means I would get a negative 3x and the positive 3x. Or I can multiply either one by a negative, so the y's would cancel out. Or I can isolate the y in the first equation and substitute it into the second one. It doesn't matter. I'm going to go ahead and do substitution. So I'm going to solve this first one for y by adding my x over. So that means y equals x minus 6. So I'm going to substitute. All right, substitute over here. I'm going to substitute that y value in. So now I have 3x plus x minus 6 equals 2, which would be 4x minus 6 equals 2, which means 4x equals 8, which means x is 2. So I have my value of x. All I need to do now is plug it in here to get y. So if x is 2, 2 minus 6 is a negative 4. So y is equal to negative 4. So my solution is 2, negative 4. Over here in part B, I'm going to go ahead and rewrite my first equation so that it's x plus y equals negative 1. And then this is still negative 4x minus 4y equals 0. Hopefully you're going to notice something here. I'm going to go with elimination because I can multiply all of this by a positive 4, and that means I'll get 4x plus 4y equaling negative 4. Cancel out, 0 equals negative 4. That is not true. No solutions. Remember when we get a false statement like 0 equals negative 4, that means that this doesn't have any solutions. So these would be like parallel lines. In part C, I'm going to go ahead and rewrite both of them like I did earlier so that my constant is on the other side of the equal sign. So negative 3x plus 6y equals 2, and then a 7x minus 4y equals 7. Now, I don't know if it'll help or not. Actually, take that back. Okay, so let's look at what we have. Negative 3x and a positive 7x, a positive 6y and a negative 4y. So substitution might not be the easiest, so I'm going to go with elimination. But you can definitely do substitution if you want. You'll just end up with maybe a little bit of a couple fractions, which is fine. Okay, so I'm going to go ahead and go with my y's. So I have a 6y and a 4y. So the common factor would be 12. So to get 12, I can multiply this first one by 2. And I can multiply this second one by 3. So that would become negative 6x plus 12y equals 4. And that would be 21x minus 12y equals 21. And so then I can combine, and I will get, that's going to be 15x, those cancel out, equals 25. So that means x is equal to 5/3. And so now that I know my value of x, I can plug it back in. I'm going to go ahead and plug it into this original one, because then I'll get negative 3 times 5/3, which will give me a nicer number, plus 6y equals 2. That's going to be negative 5 plus 6y equals 2. So that's going to be 6y equals 7. So that means y is 7/6. So there is my solution, 5/3, 7/6. And then lastly, part D. So you may look at this and think, oh my goodness, this is so, overwhelming. There's so many fractions. Easy thing for us to do is to get rid of those fractions. So notice in the second one, I can multiply by 4 and everything will, it'll all be whole numbers. So I'm going to go ahead and rewrite that. So that would be 2x plus y equals 10. And in my top one, I can't multiply by 5, but I can multiply by 15 if I wanted. So if I do that by 15, that would be 10x minus, that would be 12y equals negative 18. Hopefully I did my math there correctly. 3, 6, yeah. Okay, so then now I have 10x and a 2x, a negative 12y and a positive y, and then so I'm going to go with, let's go with substitution since we did 2 eliminations. Although elimination would be easy to do here. You can multiply the second one by 12, and then that would get rid of the y's. But let's go with substitution. So I'm going to solve this one for y. So by y equals negative 2x plus 10. So I can do 10x minus 12 times negative 2x plus 10 equals negative 18. So that'd be 10x plus 24x minus 120 equals negative 18. So that'd be 34x equals, that would be a positive 102. 120 minus 18, 102, yeah. And then 102 divided by 34. I don't have a calculator here, do I? All right. I can't do this off the top of my head. Hopefully you can. So let me go grab my calculator real quick. 102 divided by 34 is going to give us 3. And I should have known that, but it is Monday as I'm recording this. Okay, so if x is 3, then I can plug it back in. I'm going to go ahead and plug it into this right here. And so then that would be 2 times 3 plus y equals 10. So that's 6 plus y equals 10, which means y is 4. So then my solution is 3 comma 4. Okay, sorry that got a little sloppy, but that's what happens when you get those fractions and it's not as easily set up as some of the ones up here. All right, and then example 5, I'm gonna go ahead and highlight this. Okay, so we need to set up a system of equations for each problem. Make sure we're defining our variables. That's extremely important in our systems, is that we define our variables. If we're using x, y, or a, b, or maybe it's the letter of what we're trying to define or whatever, we need to define those variables. So it says the sum of the digits of a 2-digit number is 11. The ones digit is 5 more than twice the tens digit. Okay, what is the number? So we are talking about a 2-digit number, and it's giving us information about the ones digit, and it's giving us information about the tens digit. So to me, that's a red flag that those should be my 2 variables. So I'm going to do, I'll use I'll do an n for the ones digit, and I'll do a t for the tens digit. Okay, so I'm defining my variables. I have n and t. So it says the sum of the digits of the 2-digit number is 11. So that means the ones digit plus the tens digit has to be 11. The sum, adding, of the 2 digits has to be 11. So that's our first equation. Our second equation says that the ones digit is, so the ones digit is 5 more than twice the tens digit. So whatever the tens digit is times 2 plus 5. So you could obviously rewrite that as 2t plus 5. That does not matter, and you should know that. And then that's it. And then it says, what is the number? So then we would have to solve that. Okay. And so let me see if we want you guys to solve that or not, because sometimes we just ask you to set up the problem and define your variables. Okay, so they actually do want us to solve this problem. So if we have n plus t equals 11, and then n is equal to the 5 plus 2t or 2t plus 5, whatever. So what I'm going to go ahead and do is I'm going to use substitution because it's already written that way. I'm going to plug in this 5 plus 2t in for my n here. So now that's 5 plus 2t plus t equals 11. So that's 3t equals, subtracting that 5, I get 6. So that means t is 2. So that means my tens digit is 2. And then I need to plug that in and solve for n. So if I plug it in here, n plus 2 equals 11. So that means n is 9. So that means my number is 29. 2 plus 9 is 11. And the ones digit is 5 more than twice the tens digit. 2 times 2 is 4, plus 5 is 9. All right. Second one, Judas' piggy bank has dimes and quarters. If he has 53 coins worth $7.85, how many of each type of coin does he have? So if our answer is how many of each type of coin, then that means our variable needs to stand for, let's just use X and Y. So X can be the number of dimes, and then Y can be the number of quarters. Okay. He has 53 coins worth $7.85. So that means he has 53 coins. The number of dimes plus the number of quarters is 53. And we also know that it's worth $7.85. Well, if I know that for every dime I'm getting 10 cents, and for every quarter I'm getting 25 cents, then 10 cents times every dime and plus 25 cents for every quarter is going to give me that $7.85. So there are my two equations with my two variables. And so all I need to do now is solve. So this would probably be easy to do substitution or elimination. I'm going to go ahead and use elimination. What I will do is I will multiply this bottom equation by 10. That way I'm not working with decimals anymore. So this is going to turn into 10x plus 25. I'm sorry, multiplying by 100, not 10. 10x plus 25y is equal to 785. Oh, what happened there? 785. And so if I have that for my second equation, then to use elimination, I might multiply this by a negative 10. So I get negative 10x minus 10y equals a negative 530. And so then I can cancel this out and solve, and I get y to be kind of all over the place. I can get y to equal 17 if I do the math. That would be 15y equals 255. Divided by 15, I get y to be 17. And so if I know that y is 17, I can go back into this original equation, x plus y equals 53. So if I have 17 quarters, then 53 minus 17 is going to give me the number of dimes, which is 36. How many of each type of coin does he have? So 17 quarters and 36 dimes. Part C, talking about an acid solution. How many liters of a 10% acid solution and how many liters of a 50% acid solution must be mixed to produce 40 liters of a 40% acid solution? So clearly we're talking about the number of liters of these two types of solutions. So think of this as like water, and think of this as vinegar or something like that, right? So if that's an easier way of you thinking about how many liters of water and how many liters of vinegar do we need to produce 40 liters of whatever dressing, whatever we're making. So think about that. So I'll just do x and y again. So x can be the liters of 10% acid solution, and y is going to be the number of liters of the 50% acid solution. Okay, we know that we need to produce 40 liters. No matter what type of solution it is, the number of liters of 10 and the number of liters of 50% has to equal 40. Now, there's also the percentage of acid that comes into play. So, if for every liter of 10%, we're getting 10% acid for every x and 50% acid for every y, we need a 40% acid solution of those 40 liters. That's our goal. So here are our two equations. Again, I'm going to make my life a little bit easy, and I'm going to multiply that bottom one by 100 so that I can get some, or by really 10 this time, so I can get some whole numbers. So this is going to really just be like 10x plus, actually, let me do this. X plus 5y equals, that would be 160. And so if I'm using these two now, because these two are the same, then I can use elimination or substitution. I'm going to go ahead and use elimination. I'll make this a negative x minus y equals negative 40. And I had this x plus 5y equals 160. So that's going to be 4y equals 120, which means y is 30. And so if y is 30, then that means x has to be 10, because x plus y is equal to 40. How many liters of 10%? That would be 10. How many liters of the 50%? That would be 30. In a dairy processing lab, so we're talking about maybe some cows, 2 large vats contain milk. One vat tests 3% butterfat, and the other tests 7% butterfat. How much milk should be taken from each vat to produce a 10-gallon mixture testing 4.5% butterfat? The same exact problem as the acid solution. So we're talking about gallons, right? So let's say X is the gallons of 3% mixture, and then the Y is the gallons of the 7% butterfat milk, okay? So what's our goal? Our goal is that the gallons of one and the gallons of other produce 10 gallons. Our other goal, the 0.3 for every X and the 0.07 for every Y, has to be 0.045 of those 10 gallons. Again, multiplying, I might turn this into just 3x plus 7y equals 450, or 45, excuse me. And then using that x plus y equals 10. Been doing elimination a lot. We can do substitution. Maybe we'll turn this into x equals 10 minus y. And so if I plug that in right here, I'm going to use my other space real quick. So that would be 3 times 10 minus y plus 7y equals 45. So that would be 30 minus 3y plus 7y equals 45. So that would be 30 plus 4y equals 45. So that would be 4y equals 15. So that would be 15 over 4 for y. So I'm going to make this really small. Okay. And so if that's my value of y, then x is going to be 10 minus that 15 over 4, which would be 40 over 4 minus 15 over 4, which is 25 over 4. So there we go. And the last one, throwing in some geometry. 2 angles are complementary. Hopefully you know what that means. Complementary means they add up to equal 90 degrees. So it says the measure of the smaller angle is 7/8 the measure of the larger angle. Find the measure of the smaller angle. So that kind of tells us, I'm going to go ahead and go down here. That tells us that x can be the smaller angle, and then y can be the larger angle. And so I know those 2 angles have to add up to 90 degrees because that's what complementary means. So the smaller plus the larger has to equal 90. And I know that the measurement of the smaller is 7/8 the measure of the larger angle. So it spits it out for me very point blank. The measure of the smaller angle that was our x, is equal 7/8 the measure of the larger angle. So that means they're being multiplied. So this is a really easy substitution. So it would be 7/8 y plus y equals 90. So that would be 15/8 y equals 90. So that means y is going to be 48 degrees if you want to put that. So if y is 48, then I can come up here and say that x is going to have to be 42 degrees. And that is correct because 42 plus 48 does equal 90. Okay. And that's it.